Another two quadrilaterals that we'll be studying for energy, for area and perimeter are a kite and a rhombus. Now, we've got these symbols on here already because I'm confident that you know what they mean. So we've got two pairs of equal length sides. This kite has no arrows on it because we've got no parallel lines. We can see that where the lines intersect, they do so at a right angle, and we can see that these two lines are equal, these two are not. So these two are equal in length. A rhombus is a very special quadrilateral. It's a special version of a kite and a special version of a parallelogram that we looked at last lesson. So we can see that all four sides are equal in length, which is why it's a special version of a kite. We can see that all these sides are parallel, which is why it's a special version of a parallelogram. We can see that the intersects cause a right angle at the middle there. And we can also see, so one other special point, is that where the lines cross for the diagonal, we have two equal angles either side of this line and two equal angles either side of this line. This angle, this angle, this angle, and that angle are all the same. In the same way, this angle, this angle, this angle, and this angle are also all the same. So it's a very special shape, a rhombus, to work with. So let's look at the area of a kite first. The area of a kite can be worked out by looking at its length, its width, all right, so across here, the equivalent of this line here, and its height. So we have x and y. All right, so we have the width and the length, and A is equal to x times y over 2. All right, because again, we're causing this to be more like a rectangle, and just in the same way as we had triangles, we've got equivalent of our base and our height. We need to half the space because we're calculating the area of all this empty space around the shape that we need to then take away to make sure we just end up with the area of our filled shape. So the area is x times y divided by 2. All right? Now a rhombus is a special type of kite. So we can use the A equals x times y over 2 formula to work out this one, where you'll get a height and a base. All right? And because it's also a special type of parallelogram, we can use these dimensions. So instead of just having x here and y here and accounting for all that extra empty space, if you're given the height and the base, you can go straight to this and you don't have to do any dividing by 2s.